All right, good morning, everyone. My name is Seth Madore, and today I am going to be talking about quality and integrity in manufacturing. Before I get started, I do have a couple of notes to go over. One, I want this to be a conversation between us, so if you want me to clarify something at any point, just let me know. This talk should allow for time at the end for Q&A. If it goes over by any means, I don't have anything planned afterwards, so I'm more than happy to meet with you out in the hall or the lounge or what have you. The second is the title. After I put it together and I had my thing planned and Autodesk accepted it, I realized I picked a very nondescript and boring title. A better title would have been Make Better Parts and Don't Be an Ass to Your Customers. I don't think Autodesk would have supported that idea. I don't believe there's ever been a better time to be in manufacturing, personally. The cost of equipment has come down dramatically over the last 10 years. Used equipment can be had for less than the price of a new car. You can buy a brand new machine for the price of a new truck. Haas makes some really great entry machines. Retrofits, Tormach, Sile, all these different little small companies are popping up offering better availability and pricing. The same thing goes for tooling. It seems like every other day a new cutter manufacturer is popping up offering something better for the same price or less. Work holding, tool holding, those have all come down in prices. University of YouTube. So my generation would get out of high school, go into the shop, or they'd go into trade school, they'd get their apprenticeship and work their way up the ladder. Now we have people that are white collar individuals making the transition into the blue collar world because they have that creativity to make something. So University of YouTube, you have John Saunders with New York CNC YouTube putting out these wonderful videos on fusion and machining. You have Lars Christensen from Autodesk doing all these live YouTube lives. So you have no shortage of information, and you can learn something very quickly. Software. One of the biggest hurdles that I experienced when I first wanted to start a shop was I didn't have the ability to, I couldn't go out and spend 10 grand on Mastercam. I could get a pirated copy, I could go with BobCAD, but legal issues and quality issues was like, I can't do that. I wasn't about to spend my entire savings on a piece of software. So when Autodesk popped out with their Fusion 360, it was a dream come true for a lot of small shops, a lot of people that had the desire to do something. And I certainly took advantage of that. It's free for hobbyists, it's free for startups, it's free for students. If you want to buy the version because you don't qualify, it's $300 a year for the basic version. Most people go through more than that in Starbucks in a year, so the $300 is chump change. Before we get into the meat of the topic, though, I'd like to give you a little bit about myself, where I'm from and whatnot, so to explain to you why I feel qualified to talk on the issue of quality and integrity. My name is Seth Madore. I'm from Maine. I've been a machinist for 18 years. I was one of those that got out of high school, went into a shop, pushed brooms, made parts, made junk, made a lot of junk. I ended up getting paired with a couple old timers who took me under their tobacco-stained wings and showed me the ropes. It was a learning experience. The shop I was in was very set in their ways. We've done it this way for 50 years. We've got the row of bridge ports. We've got the manual equipment. They had a couple CNCs, but they weren't really interested in learning more and doing more. It's the way we've done it, and this way we'll do it. That didn't sit well with me because I wanted to learn more. I wanted to do more. I wanted to do better. I wasn't so concerned about the wages because that would come with time, but I wanted to always be pushing what I knew and how I could do it. So eventually I ended up moving on to another shop, and that happened a couple of times. Every time I'd peak on what the shop was willing to invest in for technology, I'd be like, time to find something new. So the last 8 years were spent at an aerospace shop in southern Maine, which was literally one of the best aerospace shops in New England. We had 3, 4, 5-axis, 9-axis machines, EDM. We had all these technologies at our disposal. The owner had this idea that new technology, let's try it. What's going to happen? Okay, we may lose out the first time around, but it'll pay off in the end. And so they were always willing to invest in where things mattered. And it was a really good relationship. My only problem with it was that I was putting about 400 miles a week on my car, roughly 10 hours a week spent just driving to and from work. I considered moving to another job. I considered moving closer to work. Neither one of those really worked out for me because once you get into a good shop, you really never want to step back into something less. So it was a hard sell for me. So I talked about my problems with the owner, and we came up with a decision, and that was for me to start my own shop. So I started the slow transition, and like I had mentioned, I had found Fusion 360, so that portion was all set. I picked up an old 1982 Matsuura. I was born in '79, so I was still in diapers when it rolled off the assembly line. It wasn't the best machine in the world, but it allowed me to garner some small work from local shops and widgets and whatnot. And it allowed me the capital to ultimately purchase a Mori Dura Vertical in 2015. October of last year, I quit my day job full-time and went full-time for myself. I shortly after that bought the Kitamura. As I was learning Fusion 360, it was a rough road for me because I came from a Mastercam and a Spree background, so it was always, how do I do this, how do I do that? And I'd go to the forums and I'd ask questions and I'd ask questions and ask questions. Eventually, I was going to the forums and finding people asking the same questions that I had, and so I just chime in and give them an answer, and everyone was happy. And it became a habit for me to assist people on the forums. About a year into that, Autodesk was like, hey, thanks for helping us out. Would you like to become an expert elite? I'm like, sure, sounds like a good idea. And so I became an expert elite. And that's what brings me to AU today, was that relationship that I formed with Autodesk, working with the developers, talking to the product managers. It's become a really good relationship, and I feel for both of us. So for all these things in Fusion and in HSM CAM, why am I going to talk about quality and integrity? That seems like such a, it's not sexy. You know, someone yesterday did a better tool paths, and then Lawrence did a robot integration, and there was a five-axis class. So why am I doing quality? Well, quality means a lot to me, and I want to show you this part right here that I was making. It's up on the screen. So I had been running this part for several years at my old job. It was a production job that came back in groups of 20 and 30 and every few months. I wasn't on it long term. That was good. It was tight tolerance, tight finishes, and after a while, it just became a part. You know, it had no meaning to me. It's like, yeah, that looks cool. Yeah, you talk about it. Customers love seeing it because it's all fancy, and it had no regard to me. And it was starting to devolve into just another job, just another part. January 15th of 2009, US Flight 1549 crash landed in the Hudson. What happened was Captain Sully took off from New York and promptly got smacked by a flock of geese. Takes out both turbine engines. Now, if you know commercial aerospace at all, the turbine engines produce the hydraulic power, which controls everything on the plane. The rudders, the flaps, the landing gear, and everything. Fortunately, back in the 1970s, United Technologies, Pratt & Whitney, developed this assembly. It's about the size of a conference room table, and it's got these two wings that open up, and it gathers the wind speed. Because the plane's moving, it gathers the wind speed, much like a windmill or a pinwheel, and it's able to produce the hydraulic power needed to steer. You can't do anything fancy with it, but you can at least point it away from New York City, because that would be relatively bad. Why do I talk about this part? That part that I just showed you is at the very heart of this entire system. It's buried right up in there. So all the compressed air, 3,000 PSI air, goes through that assembly. And I'm not saying that that was my part that was on that plane, but hundreds of other parts are in the sky that I've done. It's a replacement part. Every X amount of hours it gets replaced. And so it really hit me that what I do does matter, because you don't always get to know what your part does. Granted, if you are a fabricator and you're making your knife, your slingshot, your fidget spinner, you get to know what that does. But unless you have that information, that part might be saving someone's life. If the quality hadn't been held, if someone had just fudged the numbers or didn't take the regard needed, 155 people might not have walked away that day. So where do we start? There's everything, there is such a wide range of topics to talk about in regards to quality. I say we start at the beginning. Lighting. Lighting and magnification. I've been in so many shops that are dungeons. You walk in and it's this dimly lit light, all the smoke has colored the lights over the years, and you're like, how can you work? You look at the benches and there's no magnifiers there. Do you know what it's like to take a part with your naked eye and then you put it under a magnifier? You can see so many more flaws just by that simple act. And people don't think of doing that because it doesn't occur to them that they get focused on the manufacturing side of things, but the actual inspection tends to be an afterthought. So the magnification and lighting. If you're setting up a new shop, I strongly advise painting the walls and the floor. You can see I took my advice very well. I was in a hurry and it's like, I got to get the machine running and I'll paint it later. Well, that was 4 years ago. Eventually, when I move into a new shop, I'll maybe paint it. Climate control. Machine costs, tooling costs, wage costs, those are real significant expenses. Air conditioning and heat or not. Granted, if you have a 100,000 square foot facility, it's going to cost you a buttload of money to AC that place. But if you're running a small shop, 10,000 square feet, small shop, you as a machinist are going to work better when you're not fighting the sweat, when the glasses aren't falling off your face. Your machine is going to thank you because it's not growing 5 thousandths over the temperature range. When I started, I was like, I got to squeeze 2 nickels together to get a quarter. I'm going to shut off my heat while I'm at work. Well, I spent the first 2 hours every night trying to get the machine to repeat. So suck up the money. It's short money. Get your shop climate controlled. Your employees are going to thank you. You're going to work better. Everything is going to be better if you can remove that one more variable. Now, my talk is not going to be, you do all these things and you're going to be making good parts. This is a discussion of closing all the doors. You start a project and you have all these doors that are open and each one leads to failure. And so what variable can we remove that closes out one more chance of failure? This is simple. Don't fight the temperature. And on top of that, there are new machines now, like Pratt & Whitney's dealing with it down in South Berwick, Maine. They just bought like 50 DMG Moris, beautiful machines. They don't have AC, and their shop gets up to about 110, 115 degrees in the summer. The machine's shut off. And so for 4 hours, the guys are doing this because their machines can't run. Temperature compensation is this huge thing, and it really affects the part. You've got your customers measuring your part at 68 degrees, and you've made it at 105 degrees. Well, stuff's going to shrink, stuff's going to grow. Remove that variable. Clutter. No one here would say, yeah, that's my shop on the left. I've never been that bad, but I can tell you I've probably never been as clean as that. Somewhere in between is where I land. Try to keep your shop somewhat tidy. You don't need to get to Kaizen foam and job boards and all these really cool things, although that is great, but you don't need to get that far. Keep your shop clean. After you're done a job, I'm a job shop, so for me it's I gotta get the next job, and every now and again it's like stop, clean, organize, put all your stuff away. I can lose my calipers on an empty bench, so if I have anything remotely like the left side, I'd be fighting every day. Buy once and cry once. No one wants to spend money, and that's true. I mean, I need to be putting as much money back into the bank as I can. I don't want to be buying extra things. And when I'm faced with the chance of buying product A for cheap, product B for expensive, I want to go with the cheap. Problem is that I did that a lot in the beginning, and it would fail halfway through a job, or it wouldn't last me till the next job. So if you buy the quality item, I'm not talking about buying the orange vices because those are $2,000, but get a good Kurt vise, that's $400. You can get a Jergens or a Glacier machine for $300, but you don't save anything really because the quality isn't there. And the quality item is going to last the life of your career. The shop I came from had vices from the 70s because they maintain them, they clean them, they maintain them, and inspection equipment as well. Buy the quality. Shars is not quality. use the right tool for the job. I've seen this on Instagram, someone checking a thread with a bolt. Bolts aren't made to check parts. If you're making a fixture, it works. But get a thread gauge, get a ring gauge. There are specific tools for a specific reason. It's not because people just want to sell you more stuff. And on this topic of inspection, you need more than a set of calipers. I know people with 5-axis machines who are still running with basic hand tools. It works if you're manufacturing your own product, but again, if you're making something for someone, how are you going to tell them that your part is good? How did you check it? Well, the program's good. Well, who made the program? You made the program. Who made the model? You made the model. The problem is you. You were involved in everything. You need another form of measurement, another form of verification to say this part is good. And the CMM and the comparator is the next logical step to that. Creating a budget. A lot of people will, this dovetails into what I was just talking about. A lot of people view it as extra, as overhead. But if you can verify your part easily, you can get a 2-point telescoping bore gauge to measure a bore. You can also get a nice Starrett tri-mic that's digital, and there you go. It's a lot quicker and a lot more accurate. Get the ring gauge to go with it. Create the budget. Calibrating the equipment. Some people that I know that have the CMMs and the comparators, they bought them a decade ago. Well, when was the last time it was calibrated? Time and gravity, they tend to do things to people even. So calibrate your equipment, maintain your equipment, do preventive maintenance, keep logs. When was the last time I changed the filter on my oil compressor? Why is my oil compressor making that noise? Why is my machine making that noise? When was the last time you serviced it? Probing. So when people are contemplating new equipment, they tend to be like, I need to spend as little as possible. Look, you're already spending 40, 50 grand or more. Tack on another 4 or 5 grand. Tool probing is one of the most beautiful things to have as a machinist. All the shops that came from prior to my last one, we didn't have probing. So you learned how to do everything good with indicators, and you became, not to sound weird, but you became intimate with the machine. You knew if it sat for X amount of time, it would grow, and you just became a lot more of a machinist. And so when my last job, they started adopting probing, and I'm like, I don't need that, I'm a machinist. Probing's for wimps. So now that I own 2 machines, they both have probes. It's a no-brainer. It allows you to do so much more with less. I think we kind of heard that in the keynote the other day. So you can run your machine and not have to worry about thermal growth. You can, if you set up 5 stations in your machine, up 1, 2, 3, 4, and 5, you're going to load 3 into 2 and 1 into 5. No, I'm a machinist. I've done it. I'm a machinist, and I've done it. I've crashed stuff. Just because you're trying to do 5, 6, 7 things at once, you're going to get distracted. The probing, properly programmed, will prevent that. It also works to check for, did you remove the vice handle? Probe. Yep, you removed the vice handle. Good to go. Did you load the part backwards? Nope, part's loaded properly. Did you back off the tailstock? So you can do all these checks with the probing that will save you, the spindle on my Mori is 24 grand to replace. I can't justify not doing it. Tool probing, same deal, only on a lesser scale. This one helps to speed up setups. It also assists in broken tool detection. I do a lot of small tooling, 30,000 end mills, 20,000 cent mills. If it breaks, I'm going to clear out 5 other tools after that. And I really don't want to do that because I'm cheap. Each tool costs money and time. And so I can have an MO where tool's still there, good to go. Well, then the machine's sitting for the duration. The tool probe just automates that. So tool probing and spindle probing is built right into HSM, Inventor, as well as Fusion 360. Sometimes you do need to do a slight post-modification, but it's typically not too big of a deal. So I just mentioned 20 and 30,000 end mills. Well, indicate your tools. If you have a finish end mill that you need to hold an accurate size, or you have a small diameter tool, you need to indicate it. We don't all have the luxury of shrink fit or hydraulic holders. We're left with the ERs, call-outs, and the TGs and the SKs. In theory, they should be perfectly concentric because that's what they advertise. Well, it's not. You know, you may luck out and this is just a perfect marriage. Everything's good to go. Other times, well, if you bought that cheap call-out set that was half the price of the Parlec, you may have 5/10 to a thou run out just because of how it collapses. So indicate your tooling. And that's really important. With the smaller the tool, the more important it becomes. I did a study once just to prove a point to a coworker. Load the tool, don't indicate it, run it. The tool broke in 10 parts. It was just doing a little O-ring groove. Indicate the tool, same material, 35 parts. So indicating your tool matters. To indicate your tool, you want to use a magnetic base with a good 1/10 indicator, put it up against the flute, turn it backwards. If you turn it forwards, you can often chip out the tool. So turn it backwards, find the high spot, back the indicator away. On a small tool, you want to put your finger up behind the tool, little piece of brass, and tap it right on the nut. If you have the indicator there, it will shock the indicator. And if your finger's not there, small tool will typically just break right off. I did it once. Shoot, where'd my tool go? It's a bad thing to say to your boss, hey, you know that $100 oil hole drill that you just bought me? Yeah, I need another one. They tend to frown on that. Torque wrenches. Yeah, there's a few up there. So those are the torque wrenches that I use. And I want to show you the key places where I use them. So we have them to tighten the vise, we have them to tighten the jaws, and we got them to tighten fixture bolts. Using a torque wrench reduces wear on components. It reduces the destruction of the threads. We've all probably, if you've been in a machine shop, we've worked with the gorilla, who's like, yeah, I gotta tighten it more. Well, prevents that. How do you communicate to someone? Well, tighten the vise this much. No, this much. There's no numerical value tied to that. With a torque wrench, you can record the value in the program or in your documentation. Last time we ran this job, we held it down to 400 inch-pounds, 100 inch-pounds. I've done parts down to 20 thousandths thick, quite large parts. Literally 10 inch-pounds, which is just finger tight on the nut. But I needed to have a numerical value. So the torque wrench reduces wear, improves quality. Print reviewing. The devil is really in the details in this one. We get the print, our numbers are there, we're good to go. Well, what is this spec being called out here? They're calling out this coding spec. What does that mean? What are they looking for? Are there notes somewhere else in another document that control more on the print than you realize? I've got one customer, they'll just put numbers on the print, and then they'll say refer to 99,000. Go to 99,000, okay. If the dimension is this is the tolerance. And so you got to become really intimate with more than what's just on the print. Granted, if you're doing your own product, that doesn't matter so much. The title blocks and then the rev changes. That's one that's caught me a few times. Hey Seth, this part's coming back again. Oh good, load the program, good to go. Halfway through the job, oh darn, they just went from rev B to rev C. And they didn't note it anywhere else except right up there. And what is this? Oh, it's not even shown up there. You got to go to another document that they forgot to email you. And it's somewhat embarrassing to say, yeah, oops, sorry about that. Planning. If you have the ability to set up multiple operations on your machine, I suggest doing it. One case in point, let's say you're drilling a hole and you want to intersect it later on, and you don't have the tools necessary to check the depth. Set up both operations. Make sure that your numbers are coming out right and you've gone where you expect to go. Deburring, packaging, and handling. So this is a tough spot for some people. I see a lot of pictures on Instagram with a box of parts, finished parts. They're anodized, they've been beautifully machined, but they're all just clumped together. Every single one of those parts now likely has a scratch on it. You've got a male thread bouncing against a part. Now that thread gauge probably isn't going to go. Parts need to be treated with respect. Again, if you're making your product, that's a whole separate issue. I'm speaking more to the job shop where you have another customer looking at your parts. Treat your parts with respect. Egg cartons are super cheap. They're renewable. There's no reason not to keep your parts separated. Deburring, you need more than a file and a belt sander. There are beautiful products out there like Fordham hand pieces, 3M bristle discs. There are all these different tools out there that can give you a very nice deburred edge. It does involve a secondary operation, but typically they do anyway. Deburr as much as you can in the machine. It's worth the machine time to have consistency. Fail fast and fail cheap. You've got a big project. Oh, I stole that line from my friend John Saunders. He okayed that. So fail fast and fail cheap. If you're looking at a big project, prove the process. Prove that the material isn't going to grow. Let's look back at that. I'm not going to go back there because it's just going to be a pain to find it. But that picture of the part that I was doing, it shrunk 7 thousandths when I removed all that material. So all the dimensions that were initially established, they were junk. So this was in the learning pains of that job. So we set out, we made 50 of them. This ties back into my last shop. We would commit to something, this is how we're going to do it. Well, it didn't quite work that way. So run a part, prove it through all the operations, see what the material does. Make sure everything is good to go. Don't stay married to the process. For all the good things I can say about that company, that was their one thing that this is the process. The part didn't change on screen. Esprit didn't show chatter. Esprit didn't show shrinkage. Well, real life, the tooling didn't agree. The work holding didn't agree. The machinist didn't agree. Fail fast, fail cheap. Prove it's going to work. And don't stay married to the process. Okay, you've got 3 weeks into the fixturing and it's not working. Be willing to ditch it and try another thing. Don't commit that much time to it. Process reliability. If you're a machine shop trying to compete against China, Mexico, or the job shops that have 30 brother machines in a row, cycle time matters. I totally get that. I have 30 things to do in a day. Order the material, order the tooling, quote the job, program the job, inspect the part, say hi to the wife, say hi to the kids, answer emails, all these other things. If my machine takes 3 minutes longer to run, I don't care. If it takes 15 minutes longer, I don't care because I've got something else to do that I need to do anyway. So I either can diversify my time and maximize my efficiency, or I can stay in front of a machine with a 30-second cycle time. All these other things are just sitting. And so the wife and the kids get to suffer because I get to come home and do all these other things that I should have done during the day. So cycle time is my friend. I don't want to say that cycle time doesn't matter. Obviously, if you've got a job that's an hour and a half long and you found a way to bring it down to 15 minutes, do that. But if adding an extra tool adds 20 seconds to your cycle time, or it saves the process, you've got a tiny aught-80 thread to put in. That's tiny. Thread mill it. A tab broke, you've lost a $50, $100 part. Thread mill it. It'll last forever. It's going to take 30 seconds of your time. Obviously, if you've got 150 tapped holes to do, that may not be the best answer. So don't be so concerned about chasing out the cycle time. Process reliability is where it's at. And it matters even more when you start looking at employees. Here's this tight aerospace part, and I need to hire a $30 machinist. Well, no, the process is solid. You've developed it, and the process is solid. And you can literally take your son and say, Sean, run this part. Here's how you load it. I've got the probing, I've got the process established, and he can run this part that's really complex because the process is there. So you can hire lower cost employees. Not in the hope of cheating people or trying to get by with the least common denominator, but we operate on very small profit margins. So if you can reduce the labor costs just a smidge and maintain the quality, build the process reliability. Networking. If you don't know how to do something, ask. Instagram, social media, Facebook, Practical Machinists. There are many people just willing to share information and talk to you. Hey, how did you do that? I put one part up on Instagram a week ago, and I got 3 or 4 emails. Hey, how'd you make that feature? Here's how you do it. I don't have any secrets to hide. The machining world is very large, and we don't have enough of them. I want to help out the next machinist to make the same part. Competition, I'm not concerned about that. There is so much work to be had. Aerospace, oil and gas. Yes, oil and gas is busy. Car manufacturing to a little extent. Firearms. There's so many different segments and there's so much work. I'm putting work away. So I'm not concerned about the competition. I'll tell you anything I'm doing. Documentation. It sounds boring, but it's very important. How did you run the part last time? You ran it 6 months ago. How did you hold it? What did you use for tools? Now, Autodesk does have a built-in setup sheet. They apparently also have a thing against trees because it prints out on 7 pages of paper for like 2 tools. And so I worked with a Autodesk employee, George Roberts, swell guy, and we got together. We took the OEM setup sheet and we made a macro that populated this 1-page setup sheet. So I just have all my tools, how I held, what the extensions were, and I was able to capture a picture of the part. A lot of this stuff is automatically populated. It's still a work in progress. I'd like to get more data into there, but it works really well. I stole this I gained permission from my past employer to use this template. That's actually the truth. CNC programs. So you've got 1,400 programs in your machine. Did you run it? Is it a good program? How do you know it's a good program? So up here, I'll use the laser. There we go. So it posts out, I modified my post processor to output unproven and the date it was programmed. And so all this right here is built into the post processor. It goes to my machine, and after I've run it, I update the date, and I update, and this right here reflects that this was programmed a day later. So in my unproven job folder, I've got this. Oh, I made a new one, and here are some changes to it. So it allows me to know that this is the one that ran good last time. So all I got to do now is set up my tools, touch them off, and I'm pretty certain I'm going to be good to go. Small modification required. Inspection reports. How does your customer know you're checking your parts? Did you document it? How do you know your employees are checking your parts? They need to be recording dimensions. Without recording dimensions, it's good, I checked it. Did you check it? How did you check it? So did you use your microheight? Did you use the CMM? What'd you do? So this is something that you want to set up before your job is started, hopefully. I don't always get to do that. Sometimes it's go, 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 go. Oh, I got to make an inspection sheet. It helps for me that one of my customers actually requires it, so I had to do it. I can see the temptation not to do it because it does take time, and time is money. Scrap parts. Nothing's worse than getting a call from the customer saying, yeah, we found a junk part, and so now we got to look at all other 150 parts. If you scrap a part, sometimes it's easy. Oh, it's missing half the features because it got sucked out of the vise. But sometimes you got a hole that's a 1/10 oversized. Identify it. Tag it immediately. Red paint marker, scrap tags. RyanQC.com, they sell them. It's like $60 for like 300 of them. I hope not to ever go through that many. Metal stamps. So identify the scrap. You still need to be able to use it for future setups and for next time the job comes around. But identify the scrap, because the last thing you want to hear from a customer is, found a junk part that you knew there was a junk part, and it somehow got mixed up on the bench. Tag it, identify it immediately. Integrity. This is a tough one. I don't want to come across like I'm preaching, like I'm sitting up on my soapbox saying I'm better than you. The first shop I was at, let me back up a bit. Your job as the employer, as the employee, or the shop owner is to provide value. You need to generate income for your employer. You need to generate success for your customer. Yes, we make money in turn, but there's always that person above us that has to make out better than us. You're the second set of eyes on your project. If you've got a print in front of you and you've reviewed it, if there's something that looks off, ask about it. Don't just assume that, well, the engineer knew what he was doing, I'm just going to make the part. Let me give you an example. The first shop I was at, the one that was a row of Bridgeports, I had eventually worked my way onto the engineering department, the programming department. We did have 2 small CNCs. And I had this slew of prints in front of me. It was from the AutoCAD days. I think it was on revision 6. It was a little bit old. And I was looking at all the prints, and it was very clear that part A went to part B, went to part C and D, just by the bolt hole patterns, how things were oriented. The last print, the bolt hole pattern was shifted slightly and offset. Now, did that mean, was that intentional? Or were one of these parts wrong? Was something wrong? And so I shot off an email to the engineer. He was in Florida for the week. It was the middle of winter, so I was kind of envious about that. So I get an auto reply, hey, I'll be back in town on such and such a date. So like, put the brakes, don't make a part. Because to me, something was wrong. So the owner comes up and says, what's up with this project? I'm like, well, I explained the situation to him. What are you doing? He says, we could make that part, and if it's wrong, so what? It's not our problem. We get to make it twice and make a profit. And that was pretty much the death knell for me being there, because I realized the person I was working for only cared about the dollar. He didn't care about the relationship with the customer. He didn't care if his customer succeeded. He didn't care if that engineer got reamed out for making a mistake. He just wanted that dollar. So I'm like, whatever. Gonna fire me over it? Whatever, I don't care. I was at the point anyway with that job. And I cared about the relationship with the engineer. So the engineer gets back and he's like, oh my goodness, thank you for catching that. It was a bad snap in AutoCAD. Sorry. I know you're not the AutoCAD team, but you're Autodesk, so. It was just a bad snap. And he's like, you saved me so much grief from my boss, and he was a junior engineer. And we ended up getting so much more work out of it. And it's like, we could have made an extra couple grand on the job by doing this, and no one else would have known. I would have known. I would have felt like shit because of it. So you have a responsibility to, if you find a mistake, ask about it. You know, I do it now with my customers. Hey, this print has this tolerance, but the mating piece has this tolerance. I know that you're going to fusion weld the part and you need a perfectly flush surface. These numbers don't line up. Oh yeah, let's change this. Here, we authorize you to give a rev change. Okay, now I'm holding it to this. It's a small thing, but it develops that relationship with the customer that you need. University of Toronto, 1 in 7 businesses commit fraud. Yeah, they get good profit margins, but how many people here are honestly happy with corporate culture and how they deal with people and how they deal with humanity? You know, it's always, you know, oh, evil corporations. There's a reason for that. You know, how many people are in this room? If 1 in 7 of us are committing fraud, do you want to be in the elevator with that person? You know, talking to them about business? What are they going to be giving you for information? You know, at the end of the day, you need to build your relationship on honesty. Now, again, this isn't a sermon. You can do what you want. But at the end of the day, I get to know that I did the best I could for my customer, even if it didn't benefit me. You know, I put up a part on Instagram about half a year ago. Their previous vendor had failed on them. They had, going back to the buy once and cry once and use the proper tool, he was checking these plus or minus 5/10 bores way down in the bottom of a part with pins. And it's like, they were tapered out, and the customer ended up finding them, the end customer, the aerospace customer. And they rejected like 75% of the job. And my customer was like, Seth, can you help us out? And I'm like, yes. So I cleared off my machine, put it into the machine, and I ran them. And I knew they needed the parts because their customer had assembly lines down. And so I worked, you know, 14, 16-hour days, 7 days in a row. Just ask her, she'll agree. She's like, what are you still doing out here? Like, they need parts. And so I got the order done. They got the 50 parts. They were happy. And I posted it up on Instagram. You know, got this done. Customer's happy. And the first response I got was, man, I hope you charged out the wazoo for that. Like, no, they needed parts. I also knew that there was $20,000 worth of work coming up of that same part. Guess who got the job? Me, the guy that went over and did above and beyond. I got the work because I was willing to sacrifice a little bit for a long-term goal. And the long-term goal should be a better relationship based on honesty and trust. So when I get to go to a customer and say, look, I know I quoted this part at this price, but man, I took a bath on that. Is there anything we can do? They believe me because I'm always upfront and honest with them. And they work with me, or they may make it up in the next job. all you really have is your reputation. At the end of the day, are you going to be motivated by greed or by relationships? Which one's going to give the better result in the end? Lastly, there's 4 ways of getting in contact with me. I'm pretty good about my email. Yes, married to my other black wife. Instagram, Liberty Machine. I'm very frequently on here. So if you get stuck on how do I program this part, hit me up, send me a mail, whatever. More than happy to get you through it. And I just rolled out my website. I invite you all to check it out and give me some criticism. Discussion. Go right ahead, sir.
What's your take on the future of making things in the sense that additive manufacturing is now becoming a very important aspect of just building parts and pieces? What are you doing as a small business owner to be ready for that? I don't think it's going to take away from additive manufacturing, but there's hybrids to it. You can build a 3D part and then maybe do a little machine. Where do you see yourself doing that?
Sure. So I'll repeat the question for the sake of the recording station back there because it doesn't pick up that audio. So the question is as a small shop, what am I doing to prepare and accommodate additive manufacturing and its processes? That's something I'm very much aware of. As an aerospace company, I see it as much further off because of the certifications required and the tensile strengths required. So I don't believe that in that immediate segment it's going to have a huge impact on me. However, as a small shop, I'm also very interested in prototype work and launching a new idea. I don't always want to be making something for someone else the rest of my life. So maybe I'll develop this part or this idea. Printing is beautiful. 3D printing is a beautiful addition to a small shop. You can get a small printer, decent, for $2,000. It's not a lot of money. Not when you stack it up against a $50,000 to $100,000 machine. So a $2,000 3D printer, if it saves you 8 to 10 hours of fixturing time, what are you out? You're out a few bucks worth of PLA. So I believe that additive is a very good benefit to us. The laser tech, where the laser sintering that Mori has, it's very pricey, and it's going to have to be brought down a lot in price to be competitive, because subtractive is going to be faster in a lot of ways. Did that answer your question? You in the back.
Can you talk about how you keep track of what you're doing in your shop, what's happening, what you're going to do, how you use your machines, things like that? You're showing some technology around and talking about them. I'm curious what your take is on some of these things that are being shown that might help that be new and innovative ways of cloud technology.
Absolutely. So what is it called? Fusion Team, is it? Or Fusion Command? Fusion Production, there we go. So Fusion Production is going to be a beautiful addition once they've really rolled it out and smoothed it out. What I end up doing for tracking is mostly a lot of conversations by emails, and I have an Excel spreadsheet that's continuously updated. So as the customer needs change, I'll move things around and I'll set to make sure that, okay, tooling is here. Yes, good, I've got tooling on order. Material is here, the program's done. So I'll track that all manually. Because I'm a one-man shop and I have a very small number of clients, it's easy enough most of the time to keep track of things. I obviously see a time where my 2 machines aren't going to be my last 2 machines, right? Okay, so these 2 machines aren't going to be the last. Eventually I'll get into different types of manufacturing. I'll get turning, I'll get 5-axis, and I'm going to have employees. So I obviously recognize the need to track better. And I hope that Fusion Production will be playing a role in that. Did that answer, or do you want me, okay. Anyone else have feedback? Is anyone here doing something different? Is there something that you'd like to share that I didn't cover? Because quality and integrity is a very, very broad topic. And it doesn't even apply to just CNC machining, a water jet, all these other types of manufacturing. Is there something that you'd like to share with the group that you've done, that you've had good results with? All right. Well, thank you all for your time. I certainly appreciate it.